Hello, calculus students. In this problem, we're going to find some information about a ball, its velocity and its maximum height, when its height is given by this function here. So I had to make a minor modification to this problem. We're going to find the velocity of the ball after 1 second. Okay. So recall that the rate of change, velocity is the rate of change of position. So loosely speaking, right? And so velocity is the rate of change of the height in this case. So the velocity is the first derivative of the position function here. So if we're going to find the velocity of the ball after 1 second, okay, that means we take the derivative of the height, and so that's minus 32t plus 32. And then if we want to do that after 1 second, we just plug in 1 here, and we work that out, and we get that the velocity after 1 second is 0 feet per second. So that's pretty interesting. That's actually going to come into play when we work out the last problem where we find the maximum height of the ball. Because remember, when the velocity is 0, or when the first derivative is 0, we found a critical point. It turns out that at t equals 1 second, that will determine the maximum height of the ball. So let's answer the second question, which sometimes gives students a little bit of trouble. The velocity of the ball when it hits the ground. Now recall, when it hits the ground, that means that the height is 0. So you just simply set the height equal to 0. Okay? And the height function is given by minus 16t squared plus 32t. Set that equal to 0, and you get 2 times. T equals 0 seconds. That's the initial time. Of course, it's on the ground when t is 0 seconds. There's no constant term here in the height, so it's not elevated off the ground. So at 0 seconds, it starts initially on the ground, and then the ball must go up and come back down, and when it hits the ground, it's been 2 seconds. So after 2 seconds, it hits the ground. Now, we want to know what the velocity is. Remember, the velocity is the first derivative. So we found that on the previous slide. So the velocity is minus 32t plus 32. We take 2 seconds, we plug it in, and 2 times minus 32 is minus 64, plus 32 is minus 32 feet per second. It's negative because it's coming down and when it hits the ground. So that's how we find the velocity when the ball hits the ground. Okay, and then lastly, we want some height of the ball. So we take the first derivative, which turns out to be the velocity. We set that first derivative equal to 0 to find the critical points. So minus 32t plus 32 equals 0. We solve this equation, and we determine that it's t equals 1 second. And I should put my units, so that's 1 second. Okay, and so then I do a little sign chart to use the first derivative test, and for example, and I see that this derivative here, minus 32t plus 32, it's positive to the left of 1. So if you use a test point like 0, you see that h primed of 0 is positive 32. And so it's increasing to the left of 1. And if I pick a point to the right of 1, test point, I see that it's decreasing. And so if a function's increasing, then decreasing, that means we have a local max at 1. It would have been actually simpler to just use the second derivative test. If I took the second derivative, I get a minus 32, so that means that this function, h of t, is always concave down, because the second derivative is always negative. And so that means that at t equals 1 second, we have a local maximum. All right, good luck.